Hello, my name is Vega Tariyal, and today I'll be presenting Physics Lab 5. So the purpose of this lab was to observe whether differing initial heights can compensate for differing gravitational forces so that objects under different gravitational forces can hit the ground around the same time. So here's a brief overview of my result. And some basic physics principles is we have the update position formula, and this would be 0 because we would hope for them to hit the ground, so the final height would be 0. This would be 0 because the initial velocity would be 0. And g would be negative, so we'd move it to this side. And then if we were to multiply the gravitational force by, say, 2, then we'd also multiply this side by 2, and this would be the only thing left on this side. So if the gravitational force we multiply by 2, we would need the initial height to also be multiplied by 2 if we wanted the objects to land on the ground at the same time. So in this lab, the system is the object and the surroundings is the Earth, which will act on the object through gravity. So the lab procedure. To begin this lab, I took a video of an object falling, and then I tracked the object using the tracker app. Once I had tracked the video, I doubled all the y values to show how a 2 times increase in gravity would lead to a doubling of the gravitational potential energy. I also used glow script to model the first object as it was falling to the ground. So here's step 1. I took a video of an eraser falling from 0.5 meters. And then here's the lab, or the tracker app values. Here's time, and then we don't really care about x, so here's y. And then here's the glow script. I made code for the eraser falling, the initial eraser under normal Earth gravitational force. And then here's the model. And then here's step 2. I went into Google Sheets, and here's the time, and then here's the initial y values from the tracker app, and then here you can see that I doubled each value to predict what it would look like if the gravitational force was doubled and I wanted the objects to reach the ground at the same time. So you can see that here is the blue line is y1, and the red line is y2, so you can see how it comes down at the doubled rate, and then it would reach the ground at the same time. So possible errors in this lab. The first one is human error, and I don't know if you can tell here, but the eraser is very, very blurry, so clicking the object in the tracker app could have caused some errors if I misplaced the click. And then also error in calculation, so if here I say misadded a value to get the second column, that could have also created errors. And my question was, is there a way to determine how high to place an object with a certain gravitational force in order to make it fall to the ground in the same time as an object under Earth's gravitational force? So here again we have the update velocity formula. And then again, we would hope for the objects to hit the ground at the same time. So y would equal 0. The initial velocity would equal 0. And that means the gravitational force would be negative, so we'd put it on this side, and it'll be 1/2 gt squared equals y sub o. And so if we were to, say, double the gravitational force, or I already used that in my lab, so if we were to triple the gravitational force, we'd also have to triple the initial height. And using this formula, if we just multiply the initial height by the same amount that the gravitational force has changed, then we were able to come up with an initial height for an object in every gravitational force. And then the conclusion, basically, once we finish this, we can see how it is constant, like the initial height compared to the gravitational force, and how high the initial height would be set both the objects hit the ground at the same time. We can see that there's a constant relationship where if we just multiplied, if the gravitational force was a certain amount times bigger than Earth's gravitational force, we just multiply the initial height by that same value in order for both the objects to reach the ground at the same time.